Hello class, welcome to Math 124. Today's lesson is 1.1. So that means Chapter 1, Section 1 in our textbook. The title of this section is Introduction to Graphing. So let us begin. So the idea in this section is to introduce some basic concepts about graphing on the XY plane. So here I drew an XY plane where this is the x-axis. This line here is the y-axis. Okay, so the easiest thing to graph is a point on the XY plane, and I will just demonstrate how to do that through an example here. So for example, say we are asked to graph the point 2, 3. Well, what that means is x is 2, y is 3. So we put the x value first in parentheses, and then separated by a comma, we put the y value second. And how we graph this is we simply go 2 units in the x direction, 2 units up in, or 3 units up in the y direction, and put a corresponding point there. That is the point 2, 3. Right, let me graph a few more points. Say we graph negative 3, negative 2. Well, then we go negative 3 in the x direction, negative 2 in the y direction, and put a point there. This is the point negative 3, negative 2. Okay. So this is probably a concept you've seen before. I just did a quick review on how to plot some points in the x, y plane. Okay, so this is how we plot points. What if we want to plot an entire line? Well, let's look at how to do that next. And I will show you one method how to do it by using an example. So let's graph the line. Let's say 2x plus 3y equals 18 by using what is called the x, y intercepts. Okay, now what are the x, y intercepts? Well, I draw an xy plane here. The x-intercept is the point in which the line crosses the x-axis. The y-intercept is the point in which the line crosses the y-axis. So here's the y-intercept, here's the x-intercept. Okay, now I'm going to erase this because the line I drew is not necessarily the answer. Okay, now how do we find the x and y intercepts? Well, let me tell you how. To find the x-intercept, you set y equal to 0 in the equation. And solve for x. Similarly, to find the y-intercept, I'll just do an abbreviation, y-intercept, set x equal to 0 and solve for y. Okay, now I will demonstrate this through an example. So for the x-intercept here, we set y equal to 0, so we're going to plug in a 0 for the y and then solve for the x. Right, so we do 2x plus 3, now plug in 0 times 0 equals 18. Well, 3 times 0 is 0, so we're left with 2x equals 18. We divide both sides by 2 and we have x equals 9. That is the x-intercept. Similarly, for the y-intercept, we plug in a x equals 0, so 2 times 0 plus 3y equals 18. Right, so I went to the original equation, I plugged in x equals 0. That's all I did here. Okay, and now we solve for y, so 2 times 0 is 0, we can ignore that, and we are left with 3y equals 18. We divide both sides by 3, and we have y equals 6. So the x-intercept is 9, the y-intercept is 6. And as I said earlier, that means if we have the xy plane, that means the graph crosses the x-axis at the value 9 and the y-axis at the value 6. Now a line is completely determined by 2 points, so we just simply draw a line through these 2 points. And that is the graph of the equation 2x plus 3y, or sorry, what was the equation? 2x plus 3y equals 18. Right, so to summarize, we found the x-intercept by plugging in y equals 0. The reason why we did that is when y is 0, this is when y is 0, right? 0, 1, 2, 3, 4, 5, 6. So when y is 0, that corresponds to the x-axis, right? So we plugged in y equals 0, solved for x, and found this x-intercept. And here, when x equals 0, corresponds to the y-axis. So when we plugged in x equals 0 and solved for y, we found the y-intercept here to be 6. So we found these 2 intercepts and just drew a line through it. Okay. Now the next idea I want to talk about is if we are given 2 points, we want to know if they are on a line, or if they solve the equation for the line. Right, so if I was given any points on this line, and I plugged in the points to the equation, it would solve the equation. So like, whatever this point is, AB, if I plugged in an A and a B there, then we would get 18 equals 18, right? Because any of the xy points on this line will solve this equation for the line. Now I'm going to write this down a little more clearly, or I will just simply do an example here. So let's say let's use a different equation now. Let's say is 612 a solution to the equation y equals 6x minus 14. Right, now one way you can answer this is you could just graph this and look at the graph and see, is this 612 on the graph? Or an easier way is we just plug in. We'll plug in 6 to x, we'll plug in 12 to y, and we will see if we get a true result. If we get a false result, something weird like 2 equals 3 or something weird like that, then we know the given numbers do not solve the equation. So all we really need to do is plug in. When we plug in a 12 for the y, we get 12. When we plug in a 6 for the x, we get a 6 right there. So this is what I did. I plugged in the 12 for the y. I plugged in a 6 for the x, right? Because this is an x, y point. So we have 12 equals 6 times 6 minus 14. And now let's just do some number crunching. 6 times 6 is 36. Okay, 36 minus 14, what is that? 22. So we are left with the result 12 equals 22, which is clearly false. It's not a correct thing. Okay, so what happened here? Well, the logic was we assumed this was a solution and we plugged it in, but then ended up with a contradiction. So therefore what we assumed was wrong, right? This is not a solution. It does not solve the equation because we got this false result. So thus x is 6, y is 12 is not a solution. On the other hand, if we were to have got a result like 22 equals 22, then we could have concluded that it is a solution, but in this case it was not a true result. Okay, so if we're given a point and asked if it solves an equation, this is how we do it. And graphically, what that means is, I could draw a quick graph here. So the graph, let's see, we have 6x minus 14. The graph would look roughly like this, and then 612 would not be on the graph. So 612 is here, the graph of our equation is here. So this is not on the graph of the equation, and equivalently, this is not a solution to this equation. Okay, so you may encounter problems similar to this in your homework. Hopefully you will be able to answer them. I am now going to move on to a new idea here. Let's do a new idea. It's the distance formula. Right, so the idea here is we're given 2 points on the plane. Say we're given this point here, I'll call it x1, y1, right, x1, y1. We're given another point. The point could be anywhere. I will just put it here, x2, y2. Right, so x2 is here, y2 is here. Now what we want to do is find the distance between these points. So the length of this segment I will call d. Okay, now I can give you a formula for this. Let me just briefly show you where the formula comes from. It comes from drawing this triangle here and noticing this horizontal leg of the triangle has length x2 minus x1. The vertical leg of this triangle has length y2 minus y1. And some of you may remember the Pythagorean theorem, which says this length squared plus this length squared equals this length squared. So by the Pythagorean theorem, we know that d squared equals x2 minus x1 squared plus y2 minus y1 squared. That's the Pythagorean theorem. Now if we were to take the square root of both sides, then the square root and that square cancel out, leaving us with this distance formula. The distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, now if you did not understand any of this stuff here, that's okay. You can just simply memorize this formula if you'd like. But some students are interested in where the formula comes from, and this is just the Pythagorean theorem. Okay, so if we were given 2 points, could be any points on the plane, we simply plug into this formula and it spits out the distance between the points. So I will do an example. Example, find the distance between 1, 2, and 3, 4. Okay, now we could call this x1 and this y1. We could call this x2 and this y2. Now, it doesn't matter which you call x1 and y1. I could have just as easily called that x2 and that y2. But you have to be consistent. What I mean by that is if we chose this to be x2, then that has to be y2, right? We can't do x2, y1. We can't do that. That would be mixing up the formula. But whatever you call point number 1, it doesn't matter. This could have just as easily been point number 1. This doesn't matter. Right, so what I was saying is we could have done x2, y2, x1, y1. It does not matter. So let's just plug in. Well, d is big square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay? And now we just crunch the numbers. So we do 3 minus 1, that is 2. 4 minus 2 is 2. So 2 squared is 4. 2 squared is 4. 4 plus 4 is 8. And the whole thing is inside of the square root. Now when you enter this in your online homework, it probably will accept that, but if you want to simplify it, I will show you how. Let's break apart the number 8. We know 8 is 4 times 2. We know 4 is 2 times 2, right? Or in other words, the square root of 8 is the same thing as 2 times 2 squared. And that looks a little weird, but I wrote it like this just to make a point. You will see where I'm going shortly. 2 times 4 is 8. Okay, but look at this. We are allowed to do this with square roots. If we have a product inside of a square root, we could break it up as a product of square roots. Okay, now why did I do that? Well, because here we have a square root and a square, so they actually cancel out, right? And now we just have a square root of 2 times 2. But that looks a little weird. Usually we write the number out front, 2 times square root of 2. That just looks a little prettier. So these are both correct. This is the simplified version, I guess, even though it doesn't look as pretty, in my opinion, as leaving it like that, but they're smaller numbers, I guess, so they're more simple. Yeah, and that is the, this is the exact distance. If you wanted to find an approximate distance, you could put this value into a calculator and it will give you a decimal approximation. But if you're asked in your homework to find an exact distance, that just means you're going to have a square root symbol in your answer, perhaps. You won't always have one, but the square root symbol may not go away. We can't, in this case, we can't get more exact than this. We could do a decimal approximation of square root 2, but symbolically we'll just leave it like that for the exact answer. Okay, yeah, and this formula works for any points. It doesn't matter where the points are. You can always use this formula to find distance between points. So let's look at a few more examples where we use this formula. One problem you may see is the following. Say the number 11 minus 4 and 5, 6 are endpoints on the diameter of a circle. Find the radius of the circle. Okay, now don't get overwhelmed. I will explain what all these words mean. Let me draw a picture to explain what these words mean. So I'll draw a circle here. The diameter is simply the length of this line that cuts the circle in half. That's the diameter. The radius is just from the center of the circle towards there. That's the radius. So if you were to cut the diameter in half, you get the radius. That is the relationship between diameter and radius. Okay, now this problem is almost the same as the problem we just did. It's just sometimes all of these words will psych people out. But if we're given these two endpoints, right, we could find the distance by just using that formula that we just used. So if we use the distance formula with these 2 points, we will get the length of this diameter. And then we just cut the result in half and we have the radius. The radius is just half of the diameter. Right, so this problem is easier than it looks. We first just solve for the diameter, and we can use that with the distance formula. So I'll do 5 minus negative 11 squared plus 6 minus negative 4 squared. Right, so 5 minus negative 11 is 5 plus 11. We have 16 squared. 6 minus negative 4 is 6 plus 4, so that's 10 squared. Okay, 16 squared is, and we're going to get some big numbers here, that's okay, 256. 10 squared is 100. So we have 356. What is the square root of 356? Is that a nice number? Don't believe so. Anyways, let's just leave it like that, and then the radius, as I said earlier, we just cut the diameter in half. Okay, now that's the exact length. If you want to use a decimal, then put this in a calculator. And I will let you do that at home, because I do not have a calculator with me and I want you to practice that at home anyways. Okay. So the problem wasn't as bad as it looked. We just found the distance and then we cut the distance in half for the radius. Okay, so there's one last idea I want to talk about. Last idea here is a midpoint. Okay, what's a midpoint? Well, let me draw a picture to show you. See, we have a point here, x1, y1, and we have another point, x2, y2. Now, as you may have guessed, the midpoint is the point exactly in between them. I'll just call it AB. Right, the point in between is the midpoint. The formula is pretty intuitive. you just average the endpoints. So like the average value of the x numbers and the average y numbers here. Right, so we add the x numbers, cut it in half, that's the middle x number. We add the y numbers, cut it in half, that will be the middle y number. Right, or we do this number plus that number, cut it in half, that's the mid x value. Take this plus that, cut it in half, and that's the mid y value. Pretty easy formula, and our answer is inside a parentheses with a comma, because the answer is actually a point, not a number. Well, it is a number, but a two-dimensional number, an x and a y number. Okay, I'll just do an example on how to plug in. Find the midpoint I don't know, 3, -2, and 1, 4. Okay, well, the midpoint, we just add the x's, cut it in half, add the y's, cut it in half. Okay, so we have 4 cut in half, we have 2 cut in half, 4 divided by 2 is 2, 2 divided by 2 is 1. Right, easy as that. And this formula works for any 2 points on the xy plane. So really the only complication here is if you add negative numbers, just be careful with plus and minus signs. That's the only complication you could find here, but we already had that complication and it wasn't too bad. If you had 2 negatives though, just remember something like sorry, my pen is dying. If we have 2 negative numbers, remember that say -1 minus 1, that's the same as -1. Sorry, -1 minus -1, that would be like -1 plus 1. So just remember stuff like that. And yeah, we will end today's lesson here. So just a quick recap. We learned some basic ideas about graphing. We learned how to plot points. We learned how to find the x and y intercepts and connect the dots. We learned how to plug in a ordered pair or an xy point into an equation to check if the result was true or false. And we learned a distance formula and a midpoint formula. And that will be all for today's lesson. Thank you for watching. Bye-bye.